Hello friends, I am Chakraborty from Department of Geology, University of Delhi. Today in this module, we will be discussing two very important shallow marine environments. One is called delta and the other is called estuary. Now, once you go through this module, you will come to know that what is the typical kind of conditions that develop in a delta and a estuary. Number 2, you will be able to understand the processes that operate in these two environments, that depending on processes the different kind of geometries what develop in these environments, and also you will come to know about the products of this environment which will help you in identifying these environments in the ancient rock record. So, coming on to the main discussion of these two environments, first we will discuss the delta. Now, delta is one of the most important environment for the human being, simply because of the reason that about 25% of the world population that inhabits on the delta and 30% of the world oil reserve that comes from the deltaic succession. That makes this delta one of the most sought after environment in the sedimentological exercise. Delta is also very challenging because it is one of that environment where a continental and marine process they combinedly act with one another, and the mutual interaction between the agents of two different types, that is continental and marine. So, if I define a delta, how I define a delta? A delta is defined as the coastline protuberance into the sea, that how the coastline that is advancing into the sea. And when does it form? A delta is formed when there is a sea level regression. And what will happen when there is a sea level regression? That your continental agency that will move towards the sea, because there is a relative sea level fall, and that will energize the continental agency and that will try. So, by the what I want to mean by the continental agency, that is the fluvial system. So, fluvial system will try to encroach into the sea, and the sediment which will be delivered by the fluvial system into the sea, that will create a kind of deposit that we call the delta. Now, as the name implies delta, you can understand it is simply a mathematical symbol, that is the delta. So, essentially the term delta is designed based on the geometry of the body. But the problem with the sedimentologist is that the simple geometry of a delta, what you can see in the modern environment, that it is the deltaic protuberance of the sediment, that you will not get when you will see it in the rock record. So, the geometry will not be present in the rock record. So, when as a sedimentologist we will be going to interpret the rock record, then what we will be relying on? We will be relying on the processes operative in the delta, which is the main characteristic process of the delta, and the products that will be formed out of those processes, rather than relying on the geometry of the body, which is only present when you see it in the modern setting. Now, this figure explains the character of a arcuate delta. This is an example from the Krishna Godavari delta of India. You can see two river system, Krishna river and Godavari river, that is forming the delta, and the typical pattern of the arcuate delta, that you can see in some portions there are some spikes in the system, that you can see the spikes, that is a typical character of the arcuate nature of the delta. Now, there are a number of environments that is there in this delta, such as you can have the coastal basin, the delta, the self slope apron, deep sea channel and deep water fan complex that is also formed associated with this delta. This is the Google image for the Krishna Godavari delta, which clearly explains that how the geometry of a arcuate or the lobate type delta, where the marine process is more dominating than the continental and the fluvial process. A typical example of tide dominated delta. This is Bengal delta, the picture. You can see the beautiful the tidal bars that is being formed, and these tidal bars, they are at a right angle to the coastline, which is going like this. So, see the fundamental difference between the two delta. One, the earlier one what I have showed, that is the arcuate type of delta where the wave system is dominating, and this is the tide dominated Bengal delta, that the panoramic view, that how the total geometry of the delta is completely different. Now, delta, if you see that what really controls the geometry of a delta, there are three major controls of delta. Number one, it is the nature of the feeder system. Number two, it is the bathymetry of the receiving basin, that, and number three, it is the processes that operate in the deltaic system. All these three parameters, they may differ extensively, and which will cause the different kind of geometry of the delta. First, coming on to the nature of the feeder system. What are the different kind of feeder system that can feed a delta? I can have a normal fluvial system, I can have a bed plane system, I can have a alluvial fan, it can be a pyroclastic flow. So, all these different kinds of system that will create the supply of sediment into the open ocean system or a standing body of water, that causes the different kind of feeder system for the delta. Coming on to the nature of the receiving basin, that is the body where the sediment is delivered. It can be a shallow bathymetry basin, it can be a deep basin. So, depending on whether it is shallow or the deep basin, there will be the different kind of processes that will be operating. The other most important factor for a delta, that is the what is the kind of process that is operating. Suppose whether the fluvial system is dominating in a deltaic setup or the marine process is dominating in the deltaic product. By the marine process, I include both the wave and the tide. So, on one hand you have a continental system which is represented by fluvial system and its correlatives, and on the other hand there is a marine system which is dominated by the wave and tide. How they interact with one another, that basically cause the different kind of geometry of a delta. And accordingly, if I consider the geometry of a delta, there are different kinds of geometry of a delta which really is controlled by the factors what I have just described. So, we get the different kind of delta geometry. Suppose a bird foot delta. The delta geometry in the plan view, it will just look like a bird foot. When it will be formed? It will be formed when the fluvial system is more energetic and that is advancing compared to the marine system, and it looks like a bird foot delta, which is a classic example in the world, that is the Mississippi delta, which is the bird foot delta, because the continental system is more energetic than the marine system. Then I come to a condition when you have the marine system is more energetic. So, wave is more energetic. What is the geometry of the delta? That is the low bed type of delta that you get in the when the wave system become dominant. And the classic example of the low bed type of delta, that is basically the Senegal delta, our Krishna Godavari delta, all these are very classic example of the low bed type delta where the wave energy of the marine system that is dominating over the fluvial system. We also get some kind of deltaic setting, that is the arcuate delta. It all depends on whether it is a low bed or a arcuate, it all depends on what is the relative energy of the wave system. Now, when there is a tide dominated system, you also get some kind of a delta where there are large number of tidal bars and that is intersecting the tidal channels. So, all these different kind of geometry that basically cause the different geometries of the delta, that all depending on the what is the type of feeder system, their relative energy and the marine system and all this. Now, if we go to the general geometry of a delta, what are the different parts of a delta? Let us come into that. A deltaic system classically is constituted of 4 different parts, what we call delta plane, delta front, delta slope and pro delta. This is the model figure for a plan view of a low bed type of delta. As I have discussed that a low bed type of delta, there is a feeder system which is called the delta plane, and it is essentially a fluvial and the floodplain system. Then the single feeder system that gets divided into a number of feeder system. you can see the number of distributary channels that is divided from the single feeder system as the channel is losing its slope, and then the sediment which it is carrying, it is being deposited in the delta front that is in the form of the mouthbar system. So, a distributary channel mouthbar that defines the delta front. You can see the pro delta part which is away, most away from the fluvial system. So, the delta plane, delta front and pro delta part, that is being shown as a plan view on this figure, and a cross section of that clearly shows that from the proximal, that is A, point A, where the coarse grained sediment is supplied, the delta sediment become more fine grained as you go away from the source area. Now, this is a cartoon which shows that how the distributary channel that forms the mouth bar in a delta front setting. You can see that the single feeder system getting divided into a number of distributary channels, and that each distributary channel is forming a mouth bar at its mouth, and these mouth bars are basically the lenticular body encased within the marine shell, and these and in many cases around the globe, these mouth bars are forming the large scale reservoirs for the oil and supplying to the global oil reserve for the decades together. The single classic example are the mouth bars in the Mississippi Delta, which is a example of the oil reserve for decades and decades. What are the different processes that operate in this different deltaic setting? Let us come one by one. First, we come to delta plane. What is a delta plane? It is essentially a river floodplain system. The river which is forming the delta, that in the lower reaches, that is what is the delta plane. If you see the Ganges Brahmaputra delta, what is the delta plane plot? That is the Ganges and the Brahmaputra which is meeting the coastline, that portion of the river system that forms the delta plane. We get the simple river floodplain levee, what we have discussed in the low energy fluvial system in the fluvial module, that is equally applicable in the delta plane. We also get formation of coal in the delta plane system. You get the channel, the sand bodies will be lenticular, there will be levee sediments, there will be floodplain sediments, and all these together that forms a delta plane. Now, this channel system, as it will be further going down slope and that slope factor is eliminated, that channel system divulges its sediment into the form of a mouth bar, and where these bars are formed, that we call the mouth delta front part. So, a delta front part is essentially a part where the channels from their channel configuration, it become non-channelized and they deposit the sediment at the mouth of the channel, that is why it is called the mouth bar. Now, if you see how I differentiate between a channel product and a mouth bar product. A channel system, as we know, characteristically that will be fining upward, whereas the mouth bar characteristic will be coarsening upward. A channel will be at its base there will be erosional, whereas a mouth bar at its base it will be depositional. That clearly both will be lenticular in geometry, but they are very character, that whether they are fining up or coarsening up and what is the character at their base, erosional or non-erosional, that differentiate between the channel and a mouth bar system. So, depending on the mixing of these two different kind of waters, that the deltas, they can be of three different types. One is the inertia dominated delta, another is the friction dominated delta, and another is third is the buoyancy dominated delta. What is inertia dominated delta? The inertia dominated delta, they forms when we have a homopycnal mixing. That means the density of river water and the marine water, they are of equal density, and that is why the mixing of the two waters, they will be a three-dimensional mixing. And normally what kind of product of the delta, we normally get a Gilbert type delta in that kind of a setting, where you have a delta slope process that is present and there is a three-dimensional mixing of the whole body. Now we get a friction dominated delta. Now what is happening in the friction dominated delta? It is a hyperpycnal mixing. That means the river water, it is denser than the marine water. How can a river water be more dense? Because the suspended sediment cloud within that is very high. Suppose think of the Amazon delta, which is coming with a large amount of silt with it. Think of the Ganges delta, is a large amount of silt that is coming with the Ganges, because in the hinterland there is a huge orogenic belt that is called Himalaya. So, the huge amount of erosion and weathering that is causing a large amount of silt within the river system. Definitely that kind of river system that will create the much higher density of the river water, and when that river water will mix with the ocean water, that river water being more denser, that will be sinking down into the basin, and the river water will flow along the base of the basin as an underflow. The delta geometry will completely change in that case. The more important factor that will operate is the friction, and that is why you will get the ground bar, that will be middle ground bar will be formed in that delta, and the channels will be bifurcated around that ground bar. The third type of delta, that is when you have a hypopycnal mixing. That means the river water is less dense than that of the marine water. So, what will happen? That the river water will float onto the ocean water, because it is less dense, so it cannot sink. It is floating, and thereby the river water will be spreaded for a large distance within the basin, and that kind of delta will give the most largest kind of delta in the world, where the river water is less dense. So, as a buoyant action, it will be floating onto the ocean water, and then that will be sinking, forming the large delta. So, all this process, as I am discussing, that they are the different processes that will create the delta to be different type, and those deltas will be different in their nature and the geometry. Now, I come on to the kind of product a delta will form, and that I expect into a rock record. Commonly a delta, if it is a deltaic succession, because I discussed earlier that delta is a product of regression, and if the regressional history continues, then the delta will prograde, delta will advance into the sea. Now, if delta advances into the sea, what kind of succession we will expect? We expect it is the progradational succession. That means a pro-delta that will be overlain by a delta front, and delta front will be overlaid by a delta plane. Now, this figure illustrates the deltaic succession as the delta progrades, then what kind of succession it will form and how I will recognize that in the rock record. From base of this section, if we go, that it starts with a pro-delta clay with some sandstone which may be borrowed, and then you start with the laminated sand that goes into the sands of bar finger and the sands of distributary mouth bars. This is the delta front part, which is overlain by the delta plane part, that is the fluvial system, that is the feeder system, and finally at the top it is overlain by the carbonaceous clay and peat delta plane. So, the entire succession, it is basically a succession of coarsening and thickening upward from the pro delta to the delta plane. So, this simple pattern that will show a thickening as well as a coarsening upward pattern. In this, the basal part, that will be the pro delta, which will be more shelly, and with some thin beds of the sand that is the product of the high stages of the delta. It will be overlain by a delta front. Now, two major products of the delta front what we can expect. One is a distributary channel, and the second is the mouth bar. Now, the distributary channel and mouth bar in the succession, that is differentiated by means of their product, while distributary channels will show the thinning, fining upward character, the mouth bars will be showing the coarsening upward character. This delta front finally will be overlain by the delta plane. As I discussed earlier, the delta plane essentially is a fluvial, is a channel floodplain system. So, we get the channels and the floodplains. So, this is that part of the delta where we get the coal. There are ample examples around the globe where a delta is producing both oil and coal. So, how it is possible that the same environment that is giving both oil and coal? Because the delta is such a process where it starts from a continental, then it goes to a marine. So, the marine portions, as it is there in the marine part and it is within the marine shell, then that becomes a possible source for the oil, whereas the part of that is the continental part, that is the fluvial part, that becomes the source of the coal. So, that is the typical character of a delta, that depending on the type of river system and the type of the marine basin, the delta system, that becomes the different kind of geometry and the different kind of product. Now, we will discuss estuary. Now, when does estuary form? As I discussed in delta, delta forms during the time of regression, estuary form during the time of transgression. That means, when sea level is rising and the river valley is getting reworked by the marine process, that we call the estuary. So, a estuary essentially is a drowned river valley, which is being reworked by the marine process such as wave and tide. And depending on whether wave is dominating or tide is dominating, estuaries are divided into two types, that is wave dominated estuary and the tide dominated estuary. These two, the wave and tide dominated estuary, they completely differ in terms of their process as well as the product. In the wave dominated estuary, what we get, that the estuary essentially, if you say the estuary, that essentially it is a funnel shaped body. It is the more constricted part is on the upstream part and the more wide part, that is on the basin part. In case of wave dominated estuary, what we get, that we get a bayhead delta in the fluvial side, and the bars that will be forming on the marine side, that will be parallel to the coastline. So, the formation of bars parallel to the coastline and the bayhead delta, that creates a low energy environment in the middle part of the wave dominated estuary. This figure illustrates the formation of a estuary, particularly wave dominated estuary. In the plan view, as you can see, that the wave dominated estuary will form bars which are parallel to the coastline, and you will have a bayhead delta that will be formed, and in between there will be a centrally lagoon, which is a low energy environment. Only some sediments that may come as a washover deposit by the reworking of the bar system at the high tide level system or the storm, that can rework the bar and supply some kind of washover sediment into the lagoon. So, what we see in this, that if we take from this to this, this is the ocean side and this is the fluvial continental side. From here it is the river dominated, it is the marine dominated. The middle portion is of very low energy. The river current, that will be decreasing from this to this. Then the marine dominated, that is the wave and the tide, their energy will be high and that will be decreasing. So, the middle portion of this is a very low energy environment represented by the argillaceous sediment, and that on this side and this side there will be two sand body, one will be represented by bayhead delta and the other will be represented by the bar systems that will be forming into the estuary. So, this is a typical character for a wave dominated delta, where you generate a low energy environment in the middle of the estuary. Now, coming on to the tide dominated estuary. The tide dominated estuary forms when there is the tidal force that is more dominant. So, here the bars that will be formed, that will be at a high angle to the coastline. Tide dominated estuary is a much high energy environment than the wave dominated estuary. Unlike the wave dominated estuary, where there is a low energy environment in the middle of the estuary, tidal estuary do not have any low energy environment. In fact, we have upper flow regime bed, we have the tidal bar, then upper flow regime bed, and you get the tidal channel with different kind of sinuosity that occupy the different parts of the estuary. This figure illustrates the tide dominated estuary. Now, we see that it is in total contrary to the wave dominated estuary, where the bars are forming parallel to the coastline. Here the bars are forming very high angle to the coastline, and a number of tidal channels that will be entering between these bars. So, the incoming of the tidal current even to the deeper part of the estuary do not allow the formation of any low energy in the tide dominated estuary. So, the tide dominated estuary will always be a high energy, because it will allow the marine agent to intrude into the estuary and not allowing any kind of barrier for the marine energy. This is also reflected in this diagram, that energy level you can see it is always very high, there is never a low part of the energy. The river current that will be high on this side and it will be continuing even to the deeper part of the estuary. The tidal current is very high and it will come down. So, up to which the tidal current will operate, that we call that the tidal limit of the river. This is a illustration of different kind of products that we will be expecting in a tide dominated estuary. In the marine side, we will be getting the tidal sandbars. This will be followed by the upper floor regime sand flat. We get the river system, as I have discussed, that the river system will have the different kind of meandering, that you get the tidal meanders and then tidal fluvial, and finally you get the very coarse grained fluvial system. So, a tide dominated estuary is essentially a higher energy than the wave dominated estuary, and also it differs from the wave dominated estuary in the orientation of the bar system. While in the wave dominated estuary the bars are parallel to the coastline, in the tide dominated estuary bars are at a high angle to the coastline. These estuaries, depending on the relative sea level trend, that whether the relative sea level trend is rising or relative sea level trend is falling after the formation of the estuary, they can create the different kind of succession. But ideally a wave dominated estuary, that is represented by two sandy unit separated by a low energy silty and muddy unit, whereas a tide dominated estuary is essentially sandy with no muddy unit, and there is definite imprint of the tide, that what we know that the imprints of the tide, that is the bipolarity of the current system, that the sand mud alteration and the operation of the unsteady flow, all these signatures if we get, then it clearly shows that it is a tide dominated estuary. Now, if we summarize that what we have discussed in the delta and the estuary, what we find that this delta and estuary, these two are the most important shallow marine environment formed at the interface of the continental and the marine system. When continental system is more dominant during times of regression, then the deltas are formed. When the marine system is dominant during the times of transgression, then the fluvial valleys, they are drowned and the estuaries are formed. Both delta and estuary, that is very important, not because of there is a large amount of human settlement in those areas. You think of our Kaveri delta, the Krishna Godavari delta, the Kambe delta, and the kind of settlement in these deltas, and also in terms of the formation of the petroleum reservoirs at the time of transgression and regression. The different kind of geometry of the sand bed formed in the delta and the estuary, they clearly differentiate between the type of the reservoir and their geometry if they form any kind of hydrocarbon reservoir in the geological past. I believe this entire discussion has given some message to you that how important these two different environments is, and the what kind of processes that they operate and how they differ in both in the modern setting and the rock record. I hope that this module will encourage you to go through the further literature on these two different important environments. Thank you.